Good afternoon, everybody. Welcome to another exciting afternoon of Chem 170 with your host, me, Dr. White. Hi, it's Thursday, and I got a lot to do today, so I better get to it. All right, first of all, if you let me check my chat. All right, I got that taken care of. Let's go to D2L. Everybody, do you see Chem 170 test 4 information on your screen? Thank you, Jimmy. All right, let's get to it. Now, on Monday, this Monday, I'll be giving test number 4 online. You'll be able to download the password protected PDF file for test number 4 from the assignment area D2L. And that should be available sometime this Sunday afternoon, if not, maybe even Saturday. On Monday at about 4:30-ish, give or take a little, I will send out via email the password for test number 4 PDF file. You'll have until Tuesday, 5 p.m. to finish test number 4 and upload your answers to the assignment area of D2L. Please do it as a single PDF file or Word document. It should take you about 40 minutes, but take up to 2 hours. I'm in a good mood. And it will cover polymers, lipids, carbohydrates. And remember, lipids are essentially fats and oils and steroids. And it has 9 pages, 20 problems. Some of the problems have multiple parts. I've never will give a multiple choice. Now, here are the point breakdown. 54 points general, not wow, that's different. I'll explain that in a second. 54 points general knowledge, 15 points nomenclature, and 36 points reactions. There will be 1 or 2 synthesis problems. Now, how come 54 points general knowledge? Well, if I ask you, is your right hand chiral or achiral? Well, that's not nomenclature, not reactions. Well, it must be general knowledge. If I ask you, what's a thermoplastic polymer? Well, it's not nomenclature, it's not reactions, it's general knowledge. And this segment of the course, there are a lot of things you learn that didn't fit into nomenclature or reactions, so I call that general knowledge. And as always, this will not be an open notes test. On today, Thursday, I'll be doing my review, and we'll have on Monday a regular Zoom meeting and for our lab and other material. Now, important thing, please remember the deadline for the extra credit project is coming up, and that's 7/20/22. Remember, the extra credit project is optional, but if you do it right, and I'll help, you can get 10 bonus points. So it's in your favor. It's like adding 10 points to any test score. Can't hurt if you do it right. And remember, you got to create a table with 10 molecules. You can take 3 from any product. So that means you got to find 4 products. The molecules have to be organic, and they have to include at least 1 functional group that we talked about this semester. And on the table, product, name of the molecule, common or IUPAC. And if there's more than 1 functional group, you only have to name 1. If there's only 1, then you're going to have to name that. Now, listen carefully. Email me your project, not upload it to D2L before, and I'm pointing at the 7/20/22, or I can point with a pointer. And if you do that, I'll check it and get back to you and say this is right or wrong, so you can change it. And you can send it to me a second time. And if you do that, there's no reason you shouldn't get all 10 correct, So you can get 10, yes, 10 points. All right. Now, if you notice, I also put out another email and announcement because it's coming up quick. Next Monday is test 4. A week from today, Thursday, is the final exam for this course. And the final exam will be on the 21st at 2 p.m. We will not have any lecture or lab. I'll just be giving the final. And at that time, I will be emailing you the final exam PDF file. I think Wednesday or earlier, I'll have it on D2L for you to download. And you'll have until Friday morning, 11 a.m. I need to get grades out, so I can't let you stay off, go longer than that to get me your final. And you'll upload it just like you've done the test. Now, take up to 3 hours or a little more if you need to finish the actual answering the questions on the exam. Now, when I've given a similar exam, not the same, similar, over many years, most students usually take about 75 to 90 minutes, hour and a quarter, hour and a half. Notice I'm giving you 3 hours, so you got plenty of time. Now, don't get upset. It has 32 problems, 18 pages. Yeah, it's big. And I've been doing this for years. I hate to say that, and it's true though. And that type of final. I changed the final problems, just like I've done with the test. Now, some of the problems are multiple part, but never multiple choice. Now, there's 2 breakdowns I'll go through. The first one, 30 points on general knowledge, 62 on nomenclature, and 118 on reactions. And there will be a couple of synthesis problems. I don't remember how many because I got to write the test again. I don't remember in the past either. But only a few, just like on the test. Now, notice it adds up to 110. That's because there's 10 bonus points you could get on the final. Yep, like each hourly exam was 5 bonus points. The final has twice that because it's twice as long, 210 points. Now, another breakdown that will help you is test number 1. There'll be 35 points on the final from test number 1 material. There'll be 60 points from test number 2 material, 58 from test number 3, 53 from test number 4, and new material, amino acids and proteins, 4 points. And again, it adds up to 110, which 210, 10 bonus points. Now, to make your life just a little easier, just a little, the first part of the test will have questions from test 1 material. Next part has test 2 material, test 3, test 4, new material. And I thought it might make a little easier. And I'd recommend you download the final exam file and instructions in case you need them on Wednesday. I should have it, maybe even earlier. And during the final exams, since we're not going to have it, if you have any questions, email me. I'll be checking every hour or so, maybe 2 hours. And there'll be no Zoom meeting that day because you're taking the final. And I will be posting the final exam scores along with your final grade by Sunday, 3 p.m. That's the 24th, or earlier on D2L. Also, I think, what is it called here? My Access. I'll enter that. Sometimes it takes up to 24 hours before they refresh the database so you can see your final grade. But what you see in D2L, when I put it there, and I'll send out an email or announcement, you'll be able to see your final grade earlier. And what I will not do is, like I've done for the hourly exams, I will not be emailing you the points for each question. But I will tell you that if you're within 10, 15 points of a cutoff for a letter grade, I will go back and regrade your whole final. That way I make sure I didn't make a mistake. Which in all the years I've been teaching, the most I've ever made a mistake was 2 or 3 points, but that might make a difference in which way I go back and grade the whole final if the student is within 10 or 15 points of a cutoff. Now, who asked the question? Jordan asked, what time is going to be released? For sure Sunday, but do you need to get it earlier for some reason? We got to wait until I send out the passport.
No, I was wondering what time the password gets released for the final.
All right, I'm sorry, I misread what you had, because you had what time does the final get released? All right, now I understand what you said. If you look here, right up here, it will be 2 p.m. on Thursday.
Awesome, thank you.
What?
I said awesome, thank you.
You're welcome. Wow, I'm glad I'm being awesome or doing something awesome. But think of it this way: if we were face to face, you'd come to my lecture or classroom at 2 p.m. I'd give you the final, take give students up to 3 hours, because it would be on a day when we had 3 hours of class together, just like that Thursday in counting lab, and then they're done. Okay, any questions on that? All right. You all should have gotten the points per question you received for test number 3. What I like to do now is go through this test number 3 answers. Remember, I'll cut it out of the video, but if you need to see it, contact me. And don't forget, next week, Monday and Wednesday, I'll have office hours. Now, if someone emails me, I might even stay a little later on Monday and Wednesday if you need extra help. So I'm supposed to go to 7. I may go a little later if somebody needs the help, but make sure you arrive at the office hour or email me before 7, because nobody's there and nobody emailed me like they're going to be there a couple minutes late, or if they're already there, I'm closing shop. All right, let's go and do sorry about that, had a cough. All right, now, any questions about test number 3? Remember, for the final, I would use all my hourly exams as practice problems. Will they be the same ones on the final? No, but will they be similar? Yes. Any questions? Well, if I were in your shoes, I would have a question. What grade am I getting right now? Now, this is going to assume that you have handed in all the labs. And after I'm done with this, I'm going to talk about that, handing in all the labs. Well, let's go to my whiteboard. Let's open up my whiteboard. Hold on. Now I can open up my whiteboard because it's available to me to open up. All right. Again, this is assuming you've handed in all your labs, or you will, and or you will. I'll talk about that right after as I do this. Now, there are two ways you can do it. Method A. Take the sum of your 3 test scores, add it up. Obviously, that's what a sum is. Divided by 3, you'll get a number X. If X is 90 and above, you get an A, 80 to 89 B, 70 to 79 C, and 60 to 69 D, below 60 F. That's method A. Now, method B, Y equals takes the sum of your 2 highest of the 3 hourly exams, add it up, divide that by 2, you'll get Y. If Y is 90 and above, you're getting an A. If Y is 80 to 89, a B, 70 to 79 C, and then 60 to 69 D, below 60 F. Hopefully nobody's in that lower brackets. Now, there's still test number 4, that's 100 points, and the final 200, not counting the 10 bonus points. So there's a lot of points still left to go. And you should be able to do the extra credit, and that will add 10 points to you. And that's how you'd determine your grade. Any questions on that? All right, what I'd like to do next is go through the review for test number 4. Nope, the final does not get dropped, Jimmy. But let me. No, the final is your final score. But let me show you something. All right. The final has 210 points, but for the actual points or number I used to get your percentage, I used counted as a 200 point. That's why there's 10 bonus. Now, here, think of it as like 2 hourly exams. And historically, let me think about it. Historically, averages for most class are somewhere between 170 and 180. And that's the same as saying on an hourly exam, the average is 85 to 90, which is quite good. And that has been true this semester. So if you study for the final, and hopefully you do, and you've got a couple of days to study for it, which is why the way I set up this course. And next week, I'll mention in a second, I'll do something to help you get a good grade on my final, which is why students do get a good grade. You should be able to do good. So that's just an indication of my final. It is not dropped. But if you've been studying and do the practice problems, especially with your hourly exams, you'll do good on the final. Any questions on that? All right. Now, why or what's the reason students do good on my final? Because next Monday, Tuesday, Wednesday, remember the final is given on Thursday, no class, I will be doing review. of the whole semester. I'll go through the reviews for each test, and I'll also do some important practice problems for you to practice. So if you come to my lectures next Monday, Tuesday, and Wednesday, that means you're going to get about 8 to 10 hours, well, more than that, almost 11 or 12 hours of study with Dr. White, which can't hurt. I hope not. Does that help, gentlemen and ladies too? All right, let's talk. Thank you, Jimmy. Let's talk about the review I'm going to do for test number 4, which is this Monday. The last couple of days, I've been swamped to get your test out, graded and everything, and other things to the other school. I've been busy camper. I apologize, but I haven't had a chance to do it. But I hope sometime by Saturday evening, I will replace the test number 4 review that I'm going to do now with a new one that instead of being in cursive, which a lot of you can't read, will be typed out, which I think everybody can read. So the one I'm going to use now, by Saturday afternoon, evening, it will be replaced. So you can use it. But first of all, here it is. Let me close this. All right, everybody see test number 4 review. And like I said, I will be replacing this with printed, not cursive like this is. I've done the other ones already. I just had no time to do it before I did it, go through the review today. But by Saturday afternoon or evening, this will be replaced with non-cursive or printed. All right, let's talk about it. First of all, let's talk about polymers. And polymers, you should know, are macromolecules, huge molecules made up of repeating units called monomers. Now, when it comes to chemical properties of polymers, there's 2 types, or way of distinguishing by chemical property. And one you should know is an addition polymer. And you should know an addition polymer uses only one type of monomer. An example would be saran wrap or car tires. I just have tires, bicycle tires too. Now, the other type is a condensation. Now, condensation, the key thing is you use 2 or more different types of monomers. Again, condensation, bringing 2 different things together, you have 2 or more different types of monomers used. An example of that would be my water bottle, polyester. That's a condensation. I could have also put down there a nylon jacket, because asked for an item, an example used in your daily life. Now, the other way to classify polymers instead of by chemistry is by a key physical property. And the first one is called the thermoplastic. And that's a polymer once formed, can be reheated and reshaped. There should be and, not and, to form a new polymer. And this example would be a plastic water bottle is an example. Another one, which I don't have down here, would be saran wrap, could be a thermoplastic. Now, it's interesting. There's no correlation between the type of chemical polymer it is with the type of physical polymer. There's no correlation. Now, the other type of physical property is thermal set. That's once you actually make the item, the polymer, you cannot reheat it and reshape it. It's set. An example of this is car tires, or if you're sitting on a seat cushion, urethane foam, or your house is insulated with that. Now, next I talk about fats and oils. And fats and oils when we started that chapter, talking about a lipid, and a lipid is a molecule from a plant or animal or person even that's soluble in nonpolar solvent, but not soluble in water. Speaking about, I need a drink of water. And here, when we talk about lipids, there are two types. Saponifiable, you should know this, hint. And those are called fats and oils. How do you know that? The saponifiable lipids yield carboxylate anions of fatty acids in reaction with base and water. So saponifiable lipid is a fat or oil. Now, non-saponifiable lipids do not react at all with base and water, and we call those our steroids or hormones. So saponifiable, fats and oils lipid, non-saponifiable, your steroids or hormones. Now, you should know what is a fat and what is an oil. What is a fat? A solid or semi-solid triglyceride at room temperature. Ooh, the part of the teeth fell off. And what's an oil? A liquid triglyceride at room temperature. So if you have a solid or semi-solid triglyceride, it's called a fat. As the temperature you're looking at is room temperature. If you have a triglyceride that's a liquid at room temperature, we call that an oil. Now, here's the general structure for fats and oils, and it's a triglyceride. 3 esters, ester number 1, 2, 3. Remember, oil chemists, which Dr. White was for a number of years, not anymore, I don't really do that much in that area. We write our esters backwards, because this way, this is all on one side, it looks nicer. Or whatever reason, someone decided that's what oil chemists do. We're not talking petroleum. All right, now, the reactions of fats and oils you should know. The first one is, if I take this molecule, which is a representation of a fat or oil, acid and water, I'll get back glycerin plus the 3 fatty acids. Why? Ester, acid and water, alcohol you would have used to make that ester, carboxylic acid. So if I look at ester number 1, I'll get this alcohol and this carboxylic acid. Ester number 2, this alcohol and this carboxylic acid. And finally, ester number 3, this alcohol and this carboxylic acid. Now, you can also hydrolyze a fat or oil with base. And it's also called saponification. This is a way to make soap. Now here, if you take a ester reacted with base and water, and for this chapter, we'll just use sodium hydroxide, NaOH, you get back the alcohol you would have used to make that ester. But because you're in base, the carboxylic acid you make, you get reacts immediately, faster than I could do that. Immediately when they come together, they're reacted to make the carboxylate anion, the carboxylic acid you would have used to make that ester. And here I have my 3 esters. Ester number 1 gives me this alcohol plus this carboxylate anion. Ester number 2 gives me this alcohol plus this carboxylate anion. And ester number 3 gives me this alcohol plus this carboxylate anion. If I look at the clock, it's time for a break. So please come back at 2:55, 5 minutes from now, and we'll continue. See you in let's get going. I'm not too late. All right, we're going through the review for test number 4, which is this Monday after class. All right, gentlemen, do you see base hydrolysis of a fat or oil? Thank you, Jimmy. All right, let's go through this. I don't know if I finished it or even started it, but let's do it again. And if you have an ester reacting with sodium hydroxide and water, you get back the alcohol plus the carboxylate anion of the carboxylic acid you would have used to make this ester. So ester number 1, you get this alcohol plus this carboxylate anion. Ester number 2, you get this alcohol plus this carboxylate anion. And ester number 3, you get this carboxylate anion, or this alcohol, this carboxylate anion, and this together, and I forgot to mention it's here too, we call glycerin. And here we have our 3 carboxylate anions. Now, one way to make a reaction go quicker, that's called catalyze, is use a catalyst like acid or base. And we use acid, like in your stomach. I'll talk about that too in a little while. And you can also catalyze, make a reaction go faster. It's not really called catalyze, make it go faster by increasing the reaction temperature. And if you're doing a hydrolysis water, how do you get it hotter? You use high pressure steam. Steam is hot water. And therefore, this is the same, the hot water is acid and water, and you get back the alcohol plus the carboxylic acid you would have used to make that ester. So if I have a fat or oil, triglyceride, 3 esters. Ester number 1 gives this alcohol plus this carboxylic acid. Ester number 2 gives this alcohol plus this carboxylic acid. Ester number 3 gives this alcohol, so you get glycerin plus this carboxylic acid. Now, I talked about a saturated fatty acid, and that's stearic acid. And that's saturated, all the carbon-carbon bonds are single bonds. And here we have stearic acid, 18 carbons, all the carbon-carbon bonds are single bonds. You should know the structure of stearic acid. If I ask on a test, 3 points, draw the structure of stearic acid. There it is. Now, oleic acid, you should know the structure of 2. And that's a monounsaturated fatty acid. Mono 1, unsaturated, double bond. Mother Nature never, ever, ever did a triple bond. That's something organic chemists created, not Dr. White, but organic chemists did. And here, oleic acid also has 18 carbons total, but at carbon 9, you have a double bond that can be cis or trans. Notice 1 plus 7 is 8. Here's 9, 10, 17, one more, 18. Now, when we talk about fats and oils, there's 2 definitions you should be familiar with, especially for your health, and that's saturated, unsaturated. And saturated, like I just mentioned, like you learned in chapter for test number 1, is a molecule that only has carbon, fat that only has carbon-carbon single bonds. Unsaturated, it's a fat at least 1 carbon-carbon double bond. So saturated fat has at least 1 carbon-carbons, only carbon-carbon single bonds. Unsaturated fat or oil, I could have put that down too, I didn't, has at least 1 carbon-carbon double bond. Now, if you just said double bond, I'll mark it wrong because both have a carbonyl, carbon-oxygen double. We're talking about just the carbon-carbon bonds when we talk about saturated or unsaturated. Now, something you should know. Tallow is what we call beef fat in the chemical industry. And then there are 2 different grades of pig's fat, white grease, not named after me, but and yellow grease. And for this class, you should know I use the following representation for yellow grease, white grease, and tallow. This triglyceride, or R sub S, is sterile group, R sub O, oleal, another sterile. SOS, that's my private joke. And if you don't know what SOS is, Google it. I've never done that. I'll try it. And here we have tallow, sodium hydroxide, and water. What do you get? 3 products. Really? Yep. And remember, tallow is this designation, which is a triester. An ester base in water gives an alcohol plus the carboxylate anion you would have used to make that. So if we look at this one, we have first ester giving this alcohol plus sodium stearate, R prime is R sub S. Second ester, this alcohol, R prime is R sub O, so you get this carboxylate. And the third ester, you get this alcohol, so you get glycerin, and you have R sub S again. Now you can put a 2 there, you don't, because in the reality, 3 different products, glycerin, sodium stearate, sodium oleate. And you should know how to do the same thing with acid and steam. Acid and steam will give the same thing, glycerin, and you'll get stearic and oleic acids. All right, big time no. Ooh, hold on, let's really, you really should know this. How does soap work? I expect you to know this leaving my class. You should know the structure of soap. Soap has a non-polar tail, polar head. When you wash your hands, if that's what you're trying to get the dirt off of, water alone won't do it. How do you do it? Water and soap. Well, remember, water is polar. The dirt or grease you're trying to get off your hands is non-polar. And the whole key of the puzzle, notice it's in big bold letters, like dissolves like. And what that means is, if dirt is non-polar, the soap molecules, the tail, will be attracted to it. The polar heads try and get as far away from it. And this is totally surrounded. I'm just showing a few molecules of soap around the dirt, but there are a lot more. And we call that, you should know, a micelle. And now, since the polar heads are totally surrounding on the outside, the micelle, which has the dirt in the middle, water looks at the micelle and says, oh, you're polar, I'm polar. We know like dissolves like. Let's go down the drain together. And they do. And you should know this. All right, next in this chapter, I talk about the hormones, your steroids. And the only thing I ask you to know how to do is draw the ring skeleton for any steroid. And here it is, 6 right here on the right, fused together, another 6. At the top here, another 6 fused together, and to the right, a 5-membered ring fused to that. So it's through 6, 6, up here, 6, 5. And you should know, if I asked you draw the ring skeleton of a steroid, here it is. I'll say that in slow motion. If I ask draw the ring skeleton of a steroid, here it is. That was pretty good slow motion. All right, next we talked about new chapter, carbohydrates. And later today, I'll get to the carbohydrates practice problems. And here, what is a carbohydrate? It's a polyhydroxyaldehyde or polyhydroxyketone, or molecule that upon hydrolysis becomes a polyhydroxyaldehyde or ketone. Now, when we talk about carbohydrates, I taught now the concept of chirality. And you should know, I don't have it down here, chiral or chirality means handedness. in Greek. I actually had a couple years ago, 172 students who spoke fluent Greek. In fact, they were in the same class with me, and they confirmed chirality, or chiral means handedness. Now, when we talk about chirality, there are two types of chiral objects. And one is a chiral object, and that's an object with a non-superimposable mirror image. My hands are chiral. Here's the mirror image, but they're not superimposable. If I line up the big finger, my thumbs don't line up. And that's chiral. Now, achiral is an object with a superimposable mirror image. And if I had a sewing needle, the mirror image, you could superimpose them. And you should be able to identify what's a chiral object and what's an achiral object. And we'll do some of that in the problem set. What? If you see the name left or right in a description of an object, it's always going to be chiral. If you see the name left or right in the object's name, it's always going to be chiral. Oh, look, my left hand, it's chiral. Oh, look, my right foot, it's chiral. All right, next thing we did was identify chiral carbons in a molecule. And what's a chiral carbon? A carbon atom with 4 different groups, or 4 different atoms, or a combination of 4 different atoms or groups. And I showed you that, and we'll go through that in the problem set in a little while. Next, we had enantiomers. And what's an enantiomer? That's the non-superimposable mirror image of a molecule. So if I said, draw the enantiomer of this molecule, I'm really asking, draw the mirror image of this molecule. I'll say that again. If I ask, draw the enantiomer of a molecule, I'm really asking, draw the mirror image. And we'll do some of that in the practice problems later today. Now, I showed you how this general reaction you learned in test 2, ketone or aldehyde alcohol acetal gives a hemiacetal hemiketal. And for glucose, the alcohol and the aldehyde are in the same molecule. And when it's called intramolecular, you don't need a catalyst. And this hydroxyl group attacks the carbonyl, just like the alcohol here attacks the carbonyl, and you form this long, it's easier than drawing a Hawthorne projection ring, and this opens up the hydroxyl group like there, and a hydrogen on there. Everything else stays the same. And you should know, if I give you this structure, how to draw that. If I give you this structure, you should know how to either draw glucose, or if you're smart enough to remember, this carbon on top with the hydroxyl group in a ring like this is aldehyde, you can just write down glucose. And I do the same thing for fructose. Here we have a ketone, same reaction, but in this case, like glucose, it's in the same molecule. Again, C5 hydroxyl attacks the carbonyl, opens it up to an alcohol. And you get the hemiacetal, or ketal in this case. Now, I taught you that you can have the hemiacetal or ketal, and we just did it for glucose, reacted with a separate alcohol and acid, and you replace the OH with OR. And this is the basis how Mother Nature puts together glucose molecules to make the polymer we call starch. Now, you should know sucrose, table sugar, is made up of fructose and glucose bond together. You don't have to know the structure. And therefore, if you have sucrose, you have glucose and fructose bond together. Now, starch is a polymer of glucose, which I showed you. Now, if you take 50 glucose and add some acid, guess what? You link them together by acetal formation and you form starch. Now, you should also know, since the link between different units is the acetal or ketal, you add acid and water, you get back the aldehyde or ketone plus the alcohol you would. Well, that means you have sucrose, which is glucose and fructose, add acid. What's it made of? Glucose and fructose, and you get that back. And that happens in your stomach. And if you have starch and you add acid and water, what's starch? A lot of glucose molecules linked together as an acetal, and you'll break that down and get glucose, which is why glucose is the most abundant sugar in nature, and the sugar in our blood. 1 or 2 monosaccharides we call a sugar. I'll never ask that on a test. Now, did I get your attention? No. And I should have said, hint, really no. I just did say that. I should have printed on the paper too. You should know how to describe with words and a general reaction what happens when you eat a fat or oil or something that contains fats or oils. And that's called acid hydrolysis. And the functional group in a fat or oil is an ester. So it's acid hydrolysis of an ester. Next, you should know how to draw the general reaction for that. Ester, acid, and water, you get back the carboxylic acid plus the alcohol you would have used to make that ester. Again, you should know how to describe with words and a general reaction what happens in your stomach when you eat a fat or oil. And the key functional group in a fat or oil is an ester, and that's acid hydrolysis of an ester. You should know the general reaction, which you learned for test number 3. Ester, acid, carboxylic acid, alcohol. You got the carboxylic acid you would have used to make that ester, and the alcohol you would have used to make that ester. Now, when you eat a carbohydrate, all the way at the bottom, and that is what happens. Well, what's the functional group that holds glucose together in a polymer to make up carbohydrates? Oh, and also fructose glucose. It's an acetal. And you should know how to describe with words and general reaction what happens after you chew and swallow something with a carbohydrate in it. Like good things, potato chip, French fry, never mind. Bad, Dr. White. And it's acid hydrolysis of an acetal. And you learned for test number 2, acetal ketal plus water and acid, you get back the aldehyde or ketone you would have used to make that acetal or ketal plus the alcohol. You don't have to put 2 there. And that's how you do it. All right, let's do this. Let me bring this down here. All right, any questions on that? All right, this has been a busy day. It's been a busy summer. When you compress a full semester into summer, it gets busy. But you guys have been up to it. Thank you. When I say guys, I mean everybody, gentlemen, ladies and gentlemen, you've been up to it. Thank you. All right. Let me close this. Let me Open this. You notice there wasn't a problem set for polymers. I've already asked the questions I could. All right, everybody see carbohydrate practice problems. Thank you, Jimmy. Now you can tell it's the end of the semester almost. Dr. White's getting real lazy. What's a carbohydrate? Yeah, thanks. I needed that. Give me a thumbs up. But anyways, what's a carbohydrate? That's a polyhydroxyaldehyde or polyhydroxyketone or molecule upon hydrolysis, adding water and usually acid too, becomes a polyhydroxyaldehyde or a polyhydroxyketone. Now, next things, label the following items as chiral or achiral. Chiral object, that's something that has a non-superimposable mirror image. Achiral, it has the superimposable mirror image. Now, remember the advice I gave you. If you see in the description of an object the word left or right, you immediately know it's chiral. And here, C is chiral, A is achiral. Your left foot, oh, the word left, it's chiral. And if you don't believe me, put your left foot in front of a mirror, you'll see your right foot, and they're not superimposable. Now, mitten with no leather palm, if I were to draw the mirror image, it's superimposable. And the other thing is, can you wear it on either hand? And the answer is yes. And therefore, it's not chiral. Now, a tube sock with no design or writing, and I should have also put there no toes, is that chiral or achiral? And if you draw the mirror image, hold on, I think you guys could use a big laugh. So, warning, warning, artwork from Dr. White. Tube sock. Sort of the same thing. Well, I did warn you. And if I did it better, these would be identical mirror images. You can take this, pick it up, rotate it, and it will superimpose every part on that. And therefore, that makes it achiral. Now, sewing needle will have a superimposable mirror image. A piece of rice will have a superimposable mirror image. Now, baseball glove, if you're not familiar, is like a glove you wear in the winter on one of your hands. It's a glove, not a mitten. And if you have a left glove, it only fits on your left hand. And if you were to do it, it has a non-superimposable mirror image. Also, your face has a non-superimposable mirror image, but I can show you something real quick. Touch your right cheek. Well, you know which one to touch. How do you know that? Because your face has a right and left, it's chiral. And the same thing you see me do, a car, it has a non-superimposable mirror image, it's chiral. All right, next, circle the chiral carbons in the following molecules, 3 points each. Oops. And here, what do? You look from carbon that has 4 different atoms, 4 different groups, or combination of 4 different atoms or 4 different groups. Now, if a carbon has 2 or more hydrogens or the same group, it can't be chiral, it's out. So this carbon's out, this carbon, this carbon. If we look at this carbon as a hydrogen, chlorine, methyl group, and this right here are 4 different groups. If we look at this carbon, chlorine, hydroxy group, methyl, and these 3 carbons with a chlorine, 4 different groups or atoms, is chiral. If a carbon is in a double bond or triple bond, it cannot be chiral. If a carbon is in a double or, excuse me, triple bond, it cannot be chiral. Therefore, these 2 carbons are out. This has 2 hydrogens. Remember, if a carbon has 2 or more hydrogens or anything, it can't be. This is out. That leaves this carbon, thiol, SH, hydrogen, methyl, and 3 carbons with a double bond is different than a methyl, 4 different groups. Same thing here, just a little tricky. This carbon's a double bond oxygen, that's out. Now, how many bonds to carbon? 4. And therefore, this carbon has 2 bonds, 2 minus 2, 4 minus 2 is 2 hydrogens. Same thing here, that's out. 2 hydrogens, that's out. 2 hydrogens, that's out. 2 hydrogens, that's out. It sounds like a broken record. And 3 hydrogens. The only carbon we now have to consider is this. It's got a hydrogen, ethyl, these 2 carbons that are ring, and these 2 are different, and it has 4 different groups or atoms. And the same thing here, this CH3 is out, this is CH2, 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 CH2. Each one of these has 4 different groups or atoms. Now, this is a Fisher projection. Remember, every intersectional line is a carbon. Now up here, CHO is a double bond to oxygen. That's an aldehyde, that's out. If we have here 2 hydrogens on that carbon, 2 or more of the same group or atom, that's out. But each one of these circle has 4 different groups to it. And same thing here. All right, number 3, draw the enantiomer of the following molecules. And what does that really mean? Draw the mirror image. Now, achiral carbons, you don't have to draw the mirror image. The ones that are, you do. And here, aldehyde, CH2OH, CH2OH. This hydroxyl group is closest to the mirror. So you'll see that first in the reflection. The hydrogen's farthest away. And the same thing for the rest of them. Now, cross off B. I used to have students do that. I didn't take it out of here. Sorry. And the same thing here. These 2 are achiral, then the mirror image. This hydrogen is closest. This is farthest away. This hydroxyl closest, so it'll be closest on this side to the mirror. This is farthest away. It's farthest away on that carbon. Bromine, closest, hydrogen, farthest away. And same thing, hydroxyl group. That's how you do it. And here's another one for practice. All right, here I have, you don't have to learn the structures, but it'd be a good thing to you to know. So if you wanted to use names, you can. And here, what happens when you react glucose and fructose together with acid? You make table sugar, sucrose. Now, what happens when you react a lot of glucose together with itself? You get starch. Now, here's the reaction. By the way, when I did this problem set, this should be a smooth arc, not 2 bends. I got better when I wrote tests. And here we have the cyclic form of glucose, and it's a hemiacetal. We're reacting with an alcohol and acid. You replace the hydroxyl group with OR triple prime. The rest of the molecule stays the same. The rest of the molecule stays the same. So I replace the hydroxyl group with O, and my R triple prime is ethyl. Now, everybody listen carefully. I don't know why, but this bond right here between this oxygen all the way over to this carbon, students just erase, disappear, never write. When that happens, it's wrong. So make sure you put this bond in for this reaction. Don't break it. And here I give you some more R groups, R triple prime, still stays the same here. Place OH with OR, R is a cyclohexane ring. Now, sucrose is a HEMIS or an acetal-ketal, and acid and water. Remember, sucrose is glucose and fructose hooked together. I like this special effects. And when you add acid and water, they come apart. Now, starch is made up of glucose held together. And when you add acid and water, it hydrolyzes to get back glucose. Now, G, just ignore. Amylose is just another starch. When you add acid and water, you get glucose. Any questions? Going once, going twice. Let's do some stuff that will help you on test number 4. And drawing mittens or socks won't. All right, let's look at something you should know again. You should know this. And what should you know? Well, let me show you. You have glucose. It's in equilibrium with what? Well, the general reaction, if we're intermolecular, not in the same molecule, aldehyde or ketone, alcohol plus acid, keep your eye on the carbonyl. What's attached to it stays attached. And then you get OH, and then from the alcohol, OR. Now, in glucose, the hydrox group or alcohol that is reacting with the aldehyde up here. Remember, on my software, the aldehyde will look like this, CHO, but you should know it's this. And glucose, this comes and attacks that, just like this attacks that. Now, what's not changed or involved in the chemical reaction stays the same. So all I'm doing is recopying it. And then this oxygen goes to this carbon, which has a hydrogen and a hydroxyl group. And you should know that. Next one you should know. Hold on, if you're writing this down, I'll give you a chance to catch up. If you're finished copying this down, give me a thumbs up. Thank you, Jordan. Thank you. All right, gentlemen. And one thing I should do, above the blue line is general reaction. This hydroxyl is part of this carbon. It gets crowded sometimes on a whiteboard. It gets crowded on a whiteboard in a classroom. All right, now this was for glucose, which has an aldehyde. Fructose has a ketone. And by the way, both have 6 carbons. 1, 2, 3, 4, 5, 6. And as in fructose, this is carbon C5, 1, 2, 3, 4, 5. Same thing here, carbonyl gets lowest number, so this would be 1, 2, 3, 4, 5. The one right above the CH2OH in both cases. And the same reaction aldehyde ketone, alcohol plus acid. Keep your eye on the carbonyl carbon. What's attached to it stays attached to it. Then it gets a hydroxyl group and OR. So this attacks like that. Therefore, this is going to attack right there. And this is in equilibrium because it's intramolecular. And what's not involved in the chemical reaction, I will write there, including this CH2OH, and this oxygen, you lose the hydrogen, goes all the way to this carbon, just like right here, and then you'll see on there an OH group. And you should know this. Hold on. And you should. And don't forget, when you have the ketone, not the top, which is an aldehyde, this is called fructose, which I'll never ask you to draw the structure, but it would help sometimes if you knew the name. All right, that's one thing you should know. The other thing I've already done, how does soap work? And finally, what I'd like to ask you to know how to do for test number 4 is describe with words and a general action what happens when you eat a fat or oil. Or I guess you could eat both at the same time. Put some vegetable oil on your chicken skins. That'd be different. But anyways, what happens when you eat a fat or oil? You should know how to describe with words, and that's acid, hydrolysis of, and what's the functional group in a fat or oil? And the answer is ester. And next, how do you describe this? General reaction, using a general reaction. Ester, acid, H plus, water, and you get back the carboxylic acid plus the alcohol you would have used to make that ester. And you should know that. The other thing you should know is what happens when you eat something that's bleh. Let's try that again. When you eat something that has carbohydrates. So if you eat a carbohydrate, that looks better. And what's the functional group that holds glucose together in a carbohydrate? And that's an acetal. And therefore, how do you describe it? Words, what happens in your stomach when you eat a carbohydrate? It's acid hydrolysis of an acetal. Next, how do you show that with a general reaction? Acetal or ketal for the general reaction, which works, but in real life it's just the acetal, and acid and water. You get back the, keep your eye on the carbon with the two oxygens, single bond to it. That still keeps the R double prime or R prime or hydrogen and becomes the ketone or aldehyde, carbonyl. And then these groups become an alcohol. So acid hydrolysis of a acetal occurs when you eat a carbohydrate. And you should know how to describe that with words and a general reaction, which I just went through. And with that, those are important things you should know. I think this is a good time to take a 5-minute break. It's now by my clock, 3:40. Come back at 3:45 and we'll do the lab and you'll get out early today. By midnight, no, you'll get out early. And with that, I'll see you in 5. It's lab time. But first, I got to open up the lab. Let me close this. Let me go over here. All right, gentlemen, do you see on your screen? And also, if there are any ladies watching right now, which are not here today right now, but you see developing competitive products lab on your screen. Thank you, Jordan. All right. Now, as I mentioned before, when I inherited Chem 170, the labs were awful. I mean, pitiful. And I said, you're an organic chemist. You're an industrial organic chemist. Come up with some good labs. And I did. Now, the ones you've done today are with the labs you would have done if we were in a face-to-face lab, except you'd have to generate the data. However, once you did, you've gotten the same mental exercise as students face-to-face. Well, I needed one more lab, and I was thinking, all right, challenge yourself. Let's make this a really good lab. And part of the challenge was it had to be cheap. Cheap meaning I couldn't spend a lot of money on special equipment or very fancy chemicals. And the other thing I thought about is how could I give students an experience of doing research in the chemical industry and what it's like being in the chemical industry, which for many decades I was as a senior research and development manager. So I came up with the concept for the lab developing competitive products. Now, when I worked in the chemical industry as a senior research manager, part of my job was to meet with marketing salespeople and upper management, and they'd say, we got to make more money. And they'd look at me or other chemists who were at my level, and depending on what area you're responsible for, what they were really saying is we need new products or improve our existing products. And one of the areas that was always coming up, our competitor makes this, and we don't have anything like it. They're making money. We need to have a product like theirs. And that's called developing competitive products. Now, in this lab, you will be developing a competitive product. It would be like if I were in the lab and talking to you face to face now, I'd say, you are now my research group. And the vice president of marketing and sales came to me. I was in a meeting and said, our company is making this product and we don't have anything like it. We need to make some of that type of product so we can make money too. Because a lot of chemists who work in research never figured out, I did early on, that we're hired to do one thing, help a company make money. And I did. And my research group did, big time. So what's that product? Well, let's go out into the real world. And that product, no, let's not go to Party City. You can get this anywhere, is Super Miracle Bubbles. I think you've all seen it, and I've got a YouTube of it, where you take the wand out, there's some liquid on the wand, it's a circle, and you go, and bubbles come out, and it's fun. Dr. White has always kept the kid inside. Don't lose the little kid inside you ever. Anyways, that's the product. And guess what? They make a lot of money from this stuff. How do I know? Because if you look into US patents, patents are a way of protecting ideas. It costs a lot of money to write and file a patent, lots. I don't know exactly, but it's anywhere from 5 to 7,500, 5,000 just to file it. And plus get a lawyer to help you write it and get people like me to do the research. You're talking a lot of money. So if you see patents that protect ideas how to make bubbles for kids, there's a lot of money in there, and there is. How much, I don't know, but there is. Also, the product they sell is mostly water. Anything I can sell you in a bottle that's mostly water, I'm gonna make a lot of money, because water is the cheapest chemical you can use in a product. The cheapest. Now, what is our job? Our job is to come up with a product that's equivalent to that bubble blowing solution that's being sold. And first of all, you have to come up with a test to judge your product from theirs, and I'll explain that test that I did come up with. I'm sort of sad right now. Why? Because this is a fun lab to watch students do, and they love it. But good news, whenever you want, you can do some of the experiments I'll show you on your own, in your own house or backyard or wherever. Well, I don't know about wherever. I don't think they're going to like that in a supermarket, but you get the drift. All right, so what you're going to do is come up with different formulations, I help, that form bubbles making solution, and you're going to test it. And your goal is to have a bubble that lasts as long as a commercial product. Now, what is a bubble? Good question. Oop, wrong color. A bubble. Inside the bubble is air. Outside the bubble is air. And the liquid here is made up of two main things, water and a surfactant. As you know, surfactants have a nonpolar tail and a polar head. Now, water, as you learn for how does soap work, is polar. And air, I'll teach you now, is nonpolar. And here, what happens is you get a different type of micelle. On the surface of the water and all throughout, you get the polar tail, nonpolar tail want to be near the air in the center or the air outside. And they form this type of micelle. And that holds the surface tension to form a bubble. And that's how you do it. So really a bubble is a giant micelle. Didn't think of that before, I bet. So let's look at the lab. What you're going to do is a series of experiments. And when you do experiments, the one thing I was taught, really beaten to my head by my advisor and others, is when you do research, you change one variable at a time. When you do research, you change one variable at a time. Because if you change two things and it works, which one made it work? if you change two things and it didn't work, which did they both or one stop it from working? Now, when you do experiments, research, you want to get a lot accomplished in the quickest amount of time. And we do that by what's called design of experiment, DOE, design of experiment. That's where you set up grids of experiments, you change variables, but you do it in such a way you change one variable at a time, but you can test a lot of variables very quickly. Surprise, Dr. White is really good at design of experiment, DOE, and I've helped you with this. Now, if you remember what's in that bubble blowing solution that you can go to any store and buy, like Target, Walmart, or other places. I bet they even have it at Jewel. And that is a surfactant in water. So we've got to find surfactants in water that will help make good bubbles. You're going to be looking at three of them: dishwashing soap, liquid hand soap, and laundry detergent. And you should know the structures of surfactant. And first of all, dishwashing soap, and the first for dishwashing, it's this, and this is usually about 12 carbons. So this is your long non-polar tail and polar head. And this is called lauryl sulfate, sodium lauryl sulfate. And there are other things in there, but this is the main thing that cleans things like you learned soap does. Now, in liquid hand soap, it's simpler, but to make it milder on your skin, you have this. It's similar, but a little different than dishwashing soap. And I have in a pinch used Dawn to wash my hands when I was somewhere and I couldn't get soap, but that was available. But this is milder on your hands. And here N is usually 3 to 5. And essentially you take an alcohol, ethoxylate it. Here you ethoxylate it with 1 mole of VO, ethylene oxide. Here you do 3 to 5. Then you cap it with this sulfonate, sodium sulfate. And this is liquid hand soap. Now, all, which is the laundry detergent we're going to use if we were in there. Why? Because that's what I have at home that I would bring to the lab. And that's a little different. And you should know these structures for this lab. And this is called, abbreviating it, LAS, linear alkyl sulfonate. And here is anywhere from 9 to 12 carbons. So you have your nonpolar tail and your polar head. And this is how you get your dirt off your clothes. These are the 3 surfactants we'll be using today. Now, in part A, you'll be testing the Dawn dishwashing soap, and we'll be mixing it with water. Now, one of the things I did to research this lab was I looked at some of the patents and found out that they either added glycerin or corn syrup, and also you could use cornstarch. But for this lab right now, the way I have it written, it's glycerin and corn syrup. So if we look at here's one of the grids that are like a three levels. The first level for ones, you're using the same surfactant and solution A1. If we were in the lab, you would take 2 milliliters of the dishwashing soap, 18 milliliters of water. You'd make a solution, and I'll tell you what you're going to do after you make it. You'd make an A2, which is double the amount of dishwashing soap. And that's a change. Having more surfactant, does it help or not? You don't know until you run the experiment. And now we have 4 milliliters of the soap and 16 milliliters of water. Now, as I said, some of the patents said you get better and stronger bubbles by adding glycerin. And for you to take A1, add 5 drops of glycerin, test it. You take A4, add, which is all of the remainder of A2, add 10 drops of glycerin. So here you're adding just the glycerin, here you're adding more soap and glycerin or surfactant. And finally, A5, you'd make another A2 and add 10 drops of the cornstarch. Now, how would you test it? And this is the fun part of this lab. I've got pictures that I can't show you because I didn't ask for signatures for releases. So it's just for my personal enjoyment to go back and look at some great students I've had. But anyways, you test them. And the first thing you do is you test the commercial product. And you do it a number of times, like at least 5 times, 5 bubbles. Sometimes you have outliers, you got to try it more than 5 times. And you take the average of the life of the 5 bubbles and you measure that in seconds. And a commercial product is pretty good. The bubbles last about 10 seconds before they go pop or die, however you want to call it. And if you take A1, you have the averages 8, A2, 9, A3, 12, A4, 14, and A5, 15, 14 also. Now, one of the things I tell students when you're doing this, follow proper etiquette. It's not polite to bust the bubbles of your neighbor. And that used to happen. It's not polite to blow bubbles at your neighbors or blow bubbles at Dr. White. I also warn them when you're blowing bubbles a lot and they collapse, the floor gets wet every once in a while, wipe it up. The other thing I tell students when they do this, if you try 10 times and you can't get one bubble, put down 0 for the time. Again, if you try it 10 times, you can't get one bubble, put down 0. So this is for the Dawn dishwashing soap. Part B, you're going to do something similar, but now we've changed surfactant. We've gone to the liquid hand soap. Now this is a lot more thick, viscous. So instead of measuring volume, because you'd wait all day for it to come out of a graduated cylinder, I have students doing a beaker and a also, but by weight. And it's equivalent to the volume. So here, it's the same setup. B1 is 2 grams of the liquid hand soap, 18 milliliters of water. B2, double the amount of liquid hand soap surfactant in water. And then B3, you have B1, and you put 5 drops of glycerin. B4, or not B4, never mind. Anyways, B4 is all of B2, 10 drops of glycerin. And B5 is another B2 with 10 drops of corn syrup or cornstarch. And here, if you notice, it's similar to this one, difference between part A and part B, same table, except different surfactant. And in reality, we're doing a lot of experiments, but we're only changing one variable at a time. And once again, you will measure. Now, in real life, and I tell the students too, when you're writing this in your lab book in industry, when you're doing a test like this, the commercial product you only do once. This is your benchmark. You're trying to get as good as that. And here are the different times for the liquid hand soap. Now, next, in the last part, well, the second to last part, we use, guess what? The laundry detergent. And there again, you have C1, 2 milliliters, because it's not as viscous. We can go back to volume. This amount of detergent, the surfactant, and 18 milliliters of water, and then double that amount for C2. Then C3 is C1 with 5 drops of glycerin. C4 is C2 with 10 drops. C5 is another C2 with 10 drops of corn syrup. And you do that and you measure it, and whoa, we've got 0, 0, 0. You couldn't blow any bubbles. I'll talk about this in a little while. Now, after I'd been teaching this a couple of years, some really sharp students came up to me during this lab, said, Dr. White, can we do our own? I said, sure, as long as you use the chemicals I have out, which is the Dawn, the oil, the liquid hand soap, glycerin, and cornstarch, and water. And they came up with some better formulations I did. I don't really have them down here, but that would be your own. Now, to make it real world, and when I was in the chemical industry as a manager, one of my chemists would come up to me and say, I've solved the problem. It's done. Let's write a report and tell everybody. I said, whoa, stop. I want to see it work. And then I'll sign off on it. And actually, in companies, before a report was issued, the manager, there was the actual form, the chemist would sign off, and then I would have to. And let me tell you, I'm not going to put my neck out on something I haven't seen that I know is valid. I've actually, unfortunately, on 2 occasions, and it's never fun. It never is. I've had to fire people for lying, saying they did this and it didn't really work. And luckily I caught it before it went out to the company. But once I knew they lied to me, I could never trust them again. I went to management and they agreed and we got rid of them. It's not fun. I didn't want to do it, but I knew I had to. Anyways, I would sign off. So in this lab, and it's really funny because students are now under pressure because the big boss is watching me. And I say, each partner has to blow just 2 bubbles, whatever your favorite or best solution is. Look at your data, make up some more, and it's funny. Now, the other thing when we do this, sometimes some students can't blow bubbles, their partner can. I've told students when blow, don't inhale. I've had one student do that. All right, time for me to tell you a Dr. White story. Back when I was at this one company, and there are other managers like me who knew surfactants like I did, when I joined the company, I found out that Friday afternoon, a number of the managers in the research department would go to this local tavern. They had no windows, a bar and some tables you could sit at. And we'd have a couple pictures and finish the week by blowing off steam, complaining about upper management, what idiots they are, or how stupid they did something, or complaining about our employees, how could they do that? What were they thinking? Or just talking, and we'd have a good time. And we go about an hour or so and then go home, have a pitcher or 2 of beer between a bunch of us. But this owner of this tavern, I won't tell you where it is, but probably it's a little while ago, he might not even be in business now. Anyways, he had developed a talent, and his talent was to take a pitcher and fill it 1/3 with foam, so you weren't getting as much beer as if it were filled up to the top. And if you complained, he'd say, well, go somewhere else. Well, there was one, I wish it was me, one manager who knew surfactants as good as I did was really, really upset. And he did something. Before I tell you what he did, I have to teach you that any company that sells chemicals has what's called a sample room. And a sample room someone who might buy those chemicals from another company can call up the salesman or someone and say, marketing, yeah, I'd like to try your product out. Can you send me a sample? And they will, anywhere from 4 ounces, or if you're a really big company and you need a lot, up to 5 gallons free, a big 5-gallon bucket. And I've done that when I was in the chemical industry, call up companies. And because of the companies I work for are really large ones, who you want to use, like try our product? Sure, we'll get it to you real quick. And that's what they do. Now, the other thing I need to teach you is there are 2 types of chemicals that you can get. There may be more, but let's talk about this division. One is industrial. Industrial, you never consume. It's pure chemically, but not biologically. There might be whatever in there, who knows? There's another grade called food grade chemicals. That's not only chemically pure, but it's biologically pure. There's no viruses or bacteria or anything that will get you sick like that. And this chemist ordered something. What did he order? Well, in soap, there's something called the surfactant that makes foam. And foam is essentially micelles and bubbles, which is what you're testing. Now, there are molecules, and I had to get some for a problem I had to solve, that stop things from foaming. And those are called defoamers. And the problem I had at another company was I was in charge of waste treatment besides research at this chemical plant. They also had their offices and research, 47th and Racine. We had these huge monster ponds for waste treatment. Each one was the size of a football field, about 20 feet deep. I forgot how many million gallons, I think, of waste in there. And someone dumped stuff in there that caused it to start foaming. And it started foaming over the top of the dikes. And it was like about 50 feet away from 47th Street in Chicago. And if that foam had hit 47th Street, we get sued big time or fined by this, not sued, fined by the city. We're talking $1 million or more. So the president, my boss, came to me and said, did you see what happened? No, what's going on here? Who did? I found out. Well, he just said, salve it, get rid of that foam. And I found a defoamer, and turned out the one I needed was in California. And we had a day or two before that would hit 47. And I actually had 4 drums for 1 million gallons. That's how powerful this stuff is. Flown in a private airplane from California to Chicago. That cost was less than millions of dollars in fines, and it knocked the foam down. Well, this guy who was mad about the bartender owner giving us pictures of beer with foam got a food grade defoamer. If you've ever been in a small bar, even bigger ones, you get a pitcher, they take it back, rinse it with soap and water. They have a couple of sinks with regular water, hang it up to dry. And that's how they clean them. Well, he had a little squeeze bottle, and he said, shh, to all of us. He said, food grade defoamer. He put some in, there was a little beer in the pitcher, put it in a lot, went like this, got it all over along the walls, hauled up, hey, we need a new pitcher. That day we stayed a little later, and we had a few more drinks, so we're feeling good. All of a sudden, after a while, after a few pitchers contaminated his soap sink and his rinse sinks, he couldn't put any foam on the pitchers. And was he mad? What's going on here? And the bunch of us were looking at him, we started laughing. And he finally put 2 and 2 together. You're a chemist. What'd you do? Oh, we didn't do anything. It's not anything unsafe. And he said, get out of here, never come back. And we didn't. So there are chemicals that are foamers and they're defoamers. Now, the reason I'm telling you that is in the lab, students would come to me and say, Dr. White, the laundry detergent, we can't blow bubbles. I'd go to each group and say, what's one place you never want foam? And that's the washing machine. And when I've told that, I've had a couple of students tell me stories where they knew someone, who ran out of laundry detergent and used Dawn, and their whole utility room was covered in foam. So that's today's lab, and I'm done. With that, remember, Monday, I will be doing test number 4 after our lecture and lecture on Monday. Also, next Thursday will be the final. Now, I forget to mention, but I'll do it probably tomorrow or Saturday. I will open up all the lab interfaces. If you haven't done a lab, do it, upload it, and then email me saying, this is the lab I just uploaded. Make sure you grade it. I think I'll give you until Thursday morning to get that done. And with that, I'm done. Have a great rest of the weekend. Don't forget, study for test number 4 and gang gesund. Goodbye.